Hello everyone. In this video, we will be factoring polynomial functions using Polydoku, and this is the third part. I will put the link of the first and second part in the description box below. Before we jump into this example right here, let's have a review on the roots or zeros of a function. Zeros or roots of a function are values of x that causes the function to be equal to 0. Now, there are some notations how roots are written in some problems. So in some problems, they write it this way. The roots are 5, -3, 2i, 3 plus minus I. In some problems as well, they write it differently. So they write like x is equal to 5. They also write this as x is equal to -3, x is equal to 2i, and x is equal to 3 plus I. And then this is also the other one, since it's plus and minus, so that would also be x is equal to 3 minus I. Now, if we want to change these roots here into its factored form, we are going to use the zero product property backwards. So we can go ahead and rewrite this as x minus 5 in parentheses, which means that if we equal this to 0, then we add 5 from both sides plus 5 from both sides. That's how we got x is equal to 5. So pretty much we switch the sign of this, and that would be in factored form. So in this next root right here, we can go ahead and write this as x plus 3. And this one right here can be written as x minus 2i. And this one right here in factored form, we can write this as x minus 3 plus I. And then that's the other one here is x minus 3 minus I. So this is how we change the roots into its factored form. So pretty much the trick is, if we are given the roots in either of these notation, all we need to do is to switch the sign of the root, put it next to the x, and put these two binomial inside the parentheses. Okay, going back to the example right here, so we're supposed to factor this polynomial function right here. Since our exponent or the highest exponent is 4, this polynomial function will have 4 factors. So then I can go ahead and write 4 parentheses for this. So our task is to determine what are these 4 factors. There are steps that we need to follow in order that we can determine these factors. The first step is to determine all the possible roots using the rational zero theorem. So please remember that in the rational zero theorem, we're supposed to determine the factors of both P and Q. And this will be our P and this will be our Q. So let's determine the factors for both of them. So I've set it up. We're supposed to determine the factors of P, which is 50, and the factors of Q, which is the invisible 1 right there, which is, I put the 1 here in the denominator. So then let's determine the factors of 50. Okay, since our denominator here is 1, therefore we can conclude that the possible roots for this function are the ones in the numerator. So then I can go ahead and write that up here. Okay. Since we are done writing the possible roots, we're ready to move on to the second step. The second step is to use Polydoku to test which one of these are factors. So then we're going to test each one of these. Now we're going to start with x plus 1. So our task is to determine, is x plus 1 a factor? So we're going to test each one of these. So I'm just going to write it up here. Okay, so we're going to use Polydoku in order that we can test if x plus 1 is a factor. So we're going to count these terms here. 1, 2, 3, 4, 5. Since there are 5, I'm going to make 6 vertical lines. Okay, on these boxes, I'm going to write the x plus 1 right here, so x1, and then I'm going to write these terms underneath the vertical lines. Okay, the next task is to complete everything. So we start by writing this x to the fourth power up here. So that would be x to the fourth. Now I'm going to determine what do I write here, so that if I multiply these two, it's x to the fourth. So this would be x to the third. And then I'm going to multiply these two, so that is x third right here. And I will have to subtract these two right here. So I will put a minus on this one right here. Okay, so that means 7x cubed minus 1x cubed would be 6x cubed. So I'm just gonna write, it's gonna go up here. So that is 6x cubed. So that means this is 6x squared. And so this is 6x squared. So then I'm going to again subtract these two right here, and whatever the difference is, I'm gonna write it up there. So this is again a minus. So 29x squared minus 6x squared would be 23x squared, and it's gonna go up here. So this is 23x squared, and so this one right here becomes 23x. So that is 23. And then again, I will repeat the process. I'm going to subtract these two. So 13. Oh, by the way, this is supposed to be 23x. So 13x minus 23x would be a negative 10x. So I'm going to write here negative 10x. And so this one right here should be a negative 10. And so that's a negative 10 right here. And then I will subtract these two together and put it up here. So negative 15 minus negative 10 is a negative 40. So this is our remainder right here. It's negative 40. Based on the factor theorem, if f of x is divided by a factor x minus a, then the remainder is 0. Since the remainder is not 0 here, we can conclude that x plus 1 is not a factor. Okay, since x plus 1 is not a factor, then we go ahead and move on to the next one. So we are done with x plus 1, so we go ahead and say x minus 1. So I'm just gonna write that up here. Okay, so we're testing x minus 1 a factor. So what are we going to do is we're going to count the number of terms. We're going to use Polydoku for that. 1, 2, 3, 4, 5. I'm going to have 6 vertical lines. Okay, so then I'm going to repeat the process. It's gonna be this one is gonna go up here. So this is gonna come out x to the fourth. So that means this is x to the third. And this is negative x to the third, because I'm gonna multiply these two. So then I'm going to again subtract these two right here. Whatever the answer, I will put that up here. So then this would be subtracted. So 7x cubed minus 1x cubed will come out a positive 8x cubed. And then this should come out an 8x squared then. And then this is a negative 8x squared. So then I will have to repeat the process. Okay, since I did the Polydoku and then the remainder here is 0, that means that x minus 1 is a factor, and this is based on the factor theorem. If f of x is divided by a factor of x minus a, then the remainder is 0. So I can go ahead and say that x minus 1 is a factor. Okay, since we already have a factor here, I can go ahead and write x minus 1 right here. So that's one of the factors. So then we go ahead and use this in order that we can move on to testing the rest of the possible roots here. So we're going to use this part right here. So we already narrowed it down. We started on 4. Now we're on the third power. So it's pretty much the same thing. We're going to use Polydoku in order that we can get the rest of the factors. So we're moving on to the next one. So we did the x plus 1 and x minus 1. So we're moving to x plus 2. So we're going to test it. So the one that we're going to use now, since we already have found a factor, is this one. So we're going to use this in testing for x plus 2. So there are 1, 2, 3, 4. So that means I'm going to make 5 vertical lines. Okay, so the one that I will write again will not anymore be the original one, since we already found out the first factor. And so we go ahead and use this one right here. So we're trying to narrow it down until we get all of the factors. So this one is going to go to the end of this vertical line. Okay, and then we are going to repeat the process in dividing polynomial using Polydoku. Okay, since we got a remainder of 0, this means that it is a factor, and this is based on the factor theorem that if f of x is divided by a factor of x minus a, then the remainder is 0. Since this is 0, we can go ahead and say that x plus 2 is a factor. Okay, so then we can go ahead and write x plus 2 right here. So that's x plus 2. So the leftover right now would be this part right here. So this is what we're going to factor out. So again, we remember that when we get to the second degree, we either use the box and diamond or the quadratic formula to factor, and that is the third step. So in this case right here, as you can see, there's no factor. We cannot use the box and diamond to factor this out. So what are we going to use here is the quadratic formula. So in this problem right here, I'm going to show the quadratic formula up here. Okay, so we are now trying to factor this out using the quadratic formula. From here, we can go ahead and say that our A is 1, and our B is 6, and our C is 25. So we're going to use the quadratic formula to solve for x. And again, this is the quadratic formula. Okay, so we are going to plug in the A, B, and C into the formula so that we can solve for x. So in this case right here, we can go ahead and plug those in. Okay, at this point, we already have, we remember that this 2 is the denominator of both negative 6 and 8i. So negative 6 divided by 2 is a negative 3, plus 8i divided by 2 is 4i. So this one is in standard form. And we do the same thing right here. So then we go ahead and remember that this 2 is a denominator of negative 6 and negative 8i. So then we can go ahead and say that this is x is equal to negative 3 minus 4i. Because again, we have 8i divided by 2 is 4i. Now others are going to say, like, how did you get an 8i on that one? So remember, this is a negative 64. So remember that if it's a negative, we go ahead and get the square root of it and add I to it. That represents the negative. So then we go ahead and say that is the square root of 64 is 8. Since there's a negative there, I put an I. And then I simplified it. Now, since this is a root here, remember that these ones right here are actually roots. So these are roots right here. We are supposed to find the factors. So to do, in order that we can determine the factors, we just go ahead, switch and keep, or switch and keep. So then we can go ahead and say that the two factors are x plus 3 plus 4i. So what I did was I switch and keep, switch and keep. So that's the first factor. And then the other factor would be x plus 3 minus 4i. Because again, that's switch and keep. And so these are the other two factors that would complete this factors that we have right here. So that would be x plus 3 plus 4i and x plus 3 minus 4i. And so this one right here is our factored form. And if we want to find the roots for this, these are the roots for this function. So first we have x is equal to positive 1, x is equal to negative 2, and then we have x is just these two factors that we got right here. So x is equal to negative 3 plus 4i, and then the other one here is x is equal to negative 3 minus 4i. So again, this is in general form. And this one right here is in factored form. And these are the roots right here. That's it. If you found this video helpful, hit like and subscribe for more math videos. See ya!